So the IceCube project is a new type of telescope that looks for particles from outer space. So instead of looking for light, we look for these strange particles called neutrinos. And so we think that they're going to tell us new things about the universe. This started with a professor in Madison who had this idea that maybe you could use the ice as a part of the detector. And so you need a giant instrument in order to see these particles because they're so rare, or they rarely interact. And so you needed something that was about 1 kilometer by 1 kilometer by 1 kilometer. So the two choices are either do it in water or in the ice. So it's at the South Pole we have lots of ice and a station with electricity and other things.
And this is really the guts of our project. This is called a digital optical module. The top part is the digital, and the bottom part is a very sensitive light detector, and so that's the optical part of it. So we sent almost 5,000 of these to instrument a cubic kilometer of ice at the South Pole. There are 60 of them on each string, and the data it travels down a big cable like this, and they're supported on these cables. These are so sensitive that they can detect a single photon from a particle traveling hundreds of meters away.
What happens is when the particles go through the ice, they give off light. And then by looking at the sequence and when the light was detected, we can tell which direction the particle was traveling. So what that display does is it shows, using lights, the order in which the light was detected, so that people can see, oh yeah, here's the sequence that the light was detected in the South Pole, and then they can right away visually tell, oh, that's the direction that particle was traveling when it went through the ice. So I've been trying for about 5 years to get some funding in order to get that new digital projector and get the planetarium remodeled. And so when I started this new job as the Director for Education and Outreach for the IceCube project, I was able to say that this should be an important part of what we do, is to be a leader in different ways of presenting the data and also images. And so I was able to then get some funds as a result of that new position that enabled us to buy that digital planetarium projector. And so then what we hope to do is develop new content and also open that up to other types of science, and actually even outside sciences, maybe even, or hoping that the digital film people will take advantage of that space. We hope is sometime to get an upgrade where we can have a higher end stereo system. So the one thing that's kind of avant-garde is this idea of soundscapes. So instead of just doing visual images, you actually have sounds that change and, you know, give you a sense of both volume and direction and so forth. So that's another thing we're looking at. We do shows for school groups, community groups. I hope to get it so that maybe once or twice a month, depending on how much interest there are, we'll have an open night. And as I say, we're hoping that we can get some students interested in doing some filming and actually showing like shorts and things like that.